Welcome to discussion 24. In today's discussion, we'll focus on section 4.5 on curve sketching. In this video, we will do a conceptual sketching example. All right, so the example says to sketch the graph of a function y equals f of x such that, and it needs to satisfy all of these properties that we have bullet points for. So for example, f prime of x needs to be greater than 0 on the interval from -infinity to -3. F prime of x needs to be equal to -2 on the interval from -3 to 1. We also need f of 1 to be equal to 3, and so there's a bunch of these properties. So I want to first give you 5 minutes to try this. Pause the video in 4, 3, 2, 1. Pause it and try it for 5 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it on your own first. So what I want to do is I want to first make a combined sign chart of the first derivative and the second derivative. So we've done this in other curve sketching problems before, make that combined sign chart. But usually in those questions, we have to do a whole lot of work, like take the derivative, take the second derivative, and then go do the sign charts. In this problem, I don't need to take those derivatives because the problem actually already tells me where the derivative is positive, where it's negative, and the same thing with the second derivative, where it's positive and where it's negative. And that's nice. That'll actually make this problem quicker than a typical curve sketching question. All right, so let's make a number line. So I'll make a number line, and I want to put a tick mark at any number that shows up in either these first derivative intervals or in the second derivative intervals. So for the first derivative, I see numbers like -3. So I'll put a tick mark at -3, and I see numbers like 1. I also see -infinity and +infinity, but I can't put tick marks at those. Those are just the ends of my number line. And then in the second derivative, I see values like 4, 1, which I already have, and -3, which we already have. Okay, so we have this so far. I'm going to zoom out a little bit. And now I want to keep track of the sign of my first derivative, the sign of my second derivative, and then what that tells me about the shape of the original function f. Okay, so I'll separate out some rows, and I will separate out some columns. All right, so if I look at my first derivative, this first bullet point tells me it's positive on the interval from -infinity to -3. It tells me it equals -2, so it's a specific number. It's -2 on the interval from -3 to 1. Okay, so let's write that. It's -2 there. And the derivative is negative on the interval from 1 to infinity. So in this region and this region, my first derivative is negative. If I go to the second derivative is less than 0 on the interval from 4 to infinity. So it's negative over here. The second derivative is positive on two intervals, -infinity to -3 over here, and 1 to 4. And it tells me the second derivative is exactly equal to 0 on -3 to 1. Okay, so the second derivative equals 0 on the interval from -3 to 1. And that actually makes sense, because if the first derivative was equal to -2, if I did the derivative of that one more time, I would get 0. Okay, so now let's draw the shapes of the graph. So in the first column, my derivative is positive, so my function is increasing. The second derivative is positive, so it's going to be concave up, as this sort of shape. In the second column, the first derivative is -2, which means the slope is just -2 the whole way. So this is going to be a straight line with a slope of -2. All right, third column, it's going to be decreasing and concave up. And the last column, it's decreasing concave down. Alrighty, so now I want to try to put this stuff together. All right, so I'll have y equals f of x. I'll draw some axes, so y-axis and x-axis, and I'll put some tick marks. So 1, 2, 3, 4, 5, 6, 7, 8. And then -1, 2, 3, 4, 5, 6, 7, 8. In the y direction, let's go 1, 2, 3, 4, 5, 6. And then -1, 2, 3, 4, 5, 6. All right. So I'm going to slowly put this stuff together. So we've already used all the derivative and the second derivative information in this number line. I'm going to first handle all of the other stuff. So like it tells me that intercepts, it tells me f of 1 equals 3. Those are specific points. Let's draw those. So f of 1 equals 3, let's draw that point. So this is 5 and this is 5. So when x is 1, the y value is 3. That's this point. Let me label that 1, 3. And then it also tells me, so the x-intercepts are at -1 and 6. All right, so let's label those. There's one x-intercept here when x is -1. There's going to be another one when the x value is 6. All right. So this is -1, 0, and this is 6, 0. And for the y-intercept is at y equals -2. Okay, y equals -2. That's over here. All right, so if I draw that point, if I label that point, that is 0, -2. Alrighty, and now I'm going to draw the stuff with the limits. So it says the limit as you approach 1 from the right-hand side is infinity. And the fact that I have this infinite limit as x approaches a number from either side, this is going to give me a vertical. So a vertical asymptote. Okay, so I'm going to draw just a tiny part of this as x approaches 1 from the right. My y values need to go to infinity. Okay, so I'm going to draw that vertical asymptote when x is 1. This is happening as x approaches 1. Okay, so from the right-hand side, the y values need to go to infinity. That's going to do something like this. I'm only going to draw a tiny part of the graph, so I make sure that I'm able to sort of connect this and maybe satisfy any other conditions the graph needs to have. Okay, just a tiny, tiny part there. All right, and then the limit as x approaches 1 from the left needs to be equal to -4. All right, so as you approach 1 from the left-hand side, the y values need to get close to -4. So I have this point here at 1, -4. I need to put an open circle there because I already have a closed circle when x is 1. It's up here at the point 1, 3. Okay, so this hole is going to be at 1, -4. And I'm going to start to draw this part of the graph. Between -3 and 1 on our number line, it said our graph needs to be a straight line. The slope is -2. All right, so that's going to connect through that y-intercept. Notice the slope is -2 there. Even connecting to this x-intercept, slope is still -2. And it stays like that until I reach x is -3. Okay, so if I continue with this slope, so if I keep doing this rise over run and making that be -2, this point right here will be, let me label it in blue, it'll be, whoops, sorry, -3 for the x, and then 4 for the y. Okay, so now what other limits do we have? Oh, so we have limits as x goes to infinity and as x goes to -infinity. Let me hold off on those and let me start to draw some of the other parts of the graph that are more towards the middle. Okay, so, no, let me make one comment about those limits. So this limit, oh no, not that one. This limit over here, as x goes to -infinity, that limit is 2. Because this is finite, this tells me a horizontal asymptote. There's going to be a horizontal asymptote at y equals 2. Let me draw that in. So at y equals 2. And if I look at my limit, that's saying that we approach 2 as x goes to -infinity. Okay, so that's going to be this end of the graph. This end of the graph, the y values are going to get close to 2. And from my number line, I see that part of the graph is going to sort of curve like this. So starting at where x is -3, my graph is going to curve like that and approach that horizontal asymptote. All right, so we're getting there. All right, so I've done almost all of these limits except for the one as x goes to infinity. I'll hold that off to the end. All right, let's do the next part of this number line thing. From 1 to 4, my graph needs to have this shape, decreasing concave up, until I get to x equals 4. And then when I reach x equals 4, it shifts to this decreasing concave down shape. Okay, and I'm going to make sure it goes through this x-intercept, right, because that's 6, 0, and it seems like it's going to do this sort of thing. Okay, let me just draw a better curve there. So it's decreasing concave down, something like this. And as I keep going like that, what does the limit say? The limit says as x goes to infinity, this limit should be -infinity. So the y values need to go to -infinity. So that means my graph has got to keep on going down like that. And that is my graph. This now satisfies all of our properties. As a final thing, I'm going to label local extreme points and inflection points. So this is an inflection point. Our graph is continuous there and concavity switched. Switch from concave up to concave down. I could see that in my sign chart also. And then at -3, 4, we have a local max. And that's it. That's it for local extrema and inflection points.